Alright, this video has sound. Hopefully everybody can hear it, or otherwise they're looking at me pointing at this sign and trying to get their sound going. This is a lesson on 7.5. That's Chapter 7, Section 5, from the Chapter 7 Study Guide for Geometry. This lesson is on tangent, which is basically the name for a fraction. When we take two sides off of a triangle and put them together. Now, it's not just any two sides, it's specific two sides, one that goes on the top and one that specifically goes on the bottom. But basically, that's what tangent means. It's a fraction where you take the opposite side from the angle that you've referenced and put that on the top of the fraction, and put that over the adjacent side from the angle that you've referenced. So basically on any triangle, you're going to have a corner that's called the reference angle when you're doing any type of trigonometry, which this is. Now you can see that they keep talking about angle A, angle A, angle A. That means that angle A, that's this corner right here, is our reference angle. So that's the first thing you need to look for, is what is the reference angle. I'm going to try to refocus this so we get a little better crystal clear. Yay, there we go. Okay, so the side that's opposite, that means it's the farthest away from that reference angle. That's called, surprise, surprise, the opposite. And then on this right triangle, and all of these are going to be right triangles, you should be able to recognize the longest side. That's your hypotenuse. That's what we've always called it. And then whatever side is left over after you've identified the opposite and the hypotenuse, that's called the adjacent. The word adjacent means next to, and you can see that our reference angle A, this side is right next to it. So the opposite side is length BC, and the adjacent side is length AB. If you find those lengths and put them together as a fraction, that's called the tangent fraction. Okay, so in the first few examples, we have two questions. First, they want us to find the tangent of S, which means that this corner is our reference angle. And then they want us to find the tangent of corner R, which means that would be our reference angle. So I'm going to do this as two separate questions. First, I'm going to find the tangent of corner S. So if this is my angle as my reference angle, the side that's farthest away from that is going to be my opposite. So that means that 60 is my opposite side from corner S. The hypotenuse is never going to change. That's the hypotenuse. It's always the side across from the 90-degree corner. And that means that whatever side is left over is our adjacent. So in this example, if corner S is our reference angle, this side right here, length 25, is our adjacent side. So to find the tangent of angle S, we take the opposite side length and put it on the top of the fraction, and then take the adjacent side length and put it on the bottom. So that would be 60 on the top and 25 on the bottom. Now 60 25ths can be reduced to a more simple fraction by dividing both the top and the bottom by 5. It's the greatest common factor of 60 and 25. So 60 divided by 5 is 12, and 25 divided by 5 is 5. That is the simplest fraction we can get. So that would be our fraction answer. Now if you look at the directions carefully, it says write each answer as a fraction and as a decimal rounded to 4 places. Well, the second part is easy. All you do is take your calculator and you go 12 divided by 5. So numerator divided by denominator. So 12 divided by 5. Okay, so I get 2.4. There's really only one decimal place here, So I suppose if you wanted to write all 4 decimal places, you could put zeros, but in math we don't tend to follow anything with zeros that doesn't need to be. So 2.4 is the simplest answer in decimal form. So again, for the tangent of s, they wanted 2 answers. They wanted us to write as a fraction, and then when they wanted us to write that same answer as a decimal. So we did that. This is the same number, just written in 2 different formats, fraction and decimal. Okay, now, the second question. They want us to find the tangent of corner R. So I'm going to take my little whiteout and all these little notes that I wrote for myself over here. I'm going to take them away. Okay, so there's my original triangle, right? Now this time we're going to name the sides using corner R as the reference angle. Okay? The side opposite from corner R is way over here, 25. So that is my opposite side. Hypotenuse is always the same. And then whatever side is left over must be my adjacent. So there we go. If I want to find the tangent of corner R, again, the formula for tangent is opposite over adjacent. But because we've changed reference angles, the opposite and the adjacent sides are different now. The opposite side is now 25, and the adjacent side is now 60. So we would reduce that again by dividing by 5 in the numerator and denominator, giving us 5/12 this time. Now, they want our answers to be both as a fraction, write each answer as a fraction, and write it as a decimal. So that's our fractional answer for the tangent of R. And now if we want to find the decimal version of that, we would take 5 divided by 12. 5 divided by 12 is rounded off to 4 decimal places. 0.4 is 1, 6, and then the 4th place we'd have to round that up to 7 because this is a 6, so that would be a 7. And there you go. We'll do one more example exactly like this. First, they want us to find the tangent of corner B. Here's corner B right here. So the opposite side from here would be 48. The hypotenuse is always the side opposite from your 90-degree angle. It's the longest side. And then whatever side's left over would be your adjacent. So the tangent of corner B is the opposite side length over the adjacent. So that would be 48/14. This is not a fully simplified fraction because it's not fully reduced. So we'll reduce that by dividing the top and the bottom by the greatest common factor, which is 2. So we get 24/7. Now I'll take up my calculator and I'll take 24 and divide it by 7, and they want me to round off to 4 places. Now because this is a 5 and that's a 7, we're going to round that 5 up to 6. There you go. These two are the same number. It's just this one is that number written as a fraction, and this is that number written as a decimal, or at least the approximated decimal. Now if I want to find the tangent of corner C, I have to do some renaming of sides. Hypotenuse always stays the same, but finding the tangent of corner C, here is corner C. The opposite side from there would be 14. And the hypotenuse is still 50. The adjacent would be the whatever side is left over. So it's not this one, not that one, it's got to be this one. So the tangent of C is 14 over 48. And again, we reduce that by dividing by 2. So we'd get 7/24. Now you may have figured out at this point that by exchanging the corners of reference angles, we simply take the fraction and we exchange the numerator and denominator. So if the fraction of one of our reference angles is 12/5 for tangent, and we switch to the other corner, then the tangent of that corner would be 5/12. Or here, if the tangent of this triangle on one reference angle is 24/7, and we switch to the other corner and we want to find the tangent, it would be 7/24. Now the decimals are not as easily transferred. Here we would again take 7 divided by 24 on our calculator. And we want to round this off to 4 decimal places. So we'd have 0.2917 because I wrote on my calculator. The 5th place over, that's that one, is a 6, so we'd have to round this up to 7, our 4th decimal place. And there you go. Tangent of B, both versions of the answer, and tangent C, the fraction and the decimal answer. Same number, just 2 different formats. Okay, so on the following pages we have several examples of this. Fortunately, we don't have to do double time on each one. We're just asked to find a specific value. And a lot of times they don't tell us necessarily how to round, so we'll just round it off maybe to the nearest 10th if nobody tells us what to do in that regard. Okay, so use tangent to find the leg length. So they've given us this measure right here, so we're going to use that as our reference angle. So the first thing we're going to do is we're going to start identifying the sides. The side opposite from that corner would be this one. The hypotenuse is the longest side that's opposite from the 90-degree angle. That would be the hypotenuse. And then whatever side is left over would have to be our adjacent. So they want us to use the tangent more as an equation this time, rather than a tool for calculation. So how do we do that? Well, I'm going to say that the tangent of any angle equals the opposite side from that angle on the top of the fraction and the adjacent side from that angle on the bottom. All right. So on this specific example, we have the tangent of 31 degrees, that's our angle. The opposite side length is 17, and the adjacent side length is our unknown value, or x. So how do we find x? Well, it turns out that this thing right here is the number value. We can use our calculator to find that number. So on your calculator, you should be able to find the tangent button. So what we're going to do is we're going to make sure that our calculator is in degree mode, because this is 31 degrees. So on every calculator that may be different. On this calculator, I just punch the mode button and I can see that degree is highlighted instead of radian, so I don't have to change anything. On smaller calculators, you might see a little D at the top in the thin answer screen. But hopefully you know how to recognize what mode your calculator is in first. Once you know that it's in degree mode, or you've changed it into degree mode, then you can go ahead and find the tangent of 31 degrees. Now I've typed in tangent first and then 31. Your calculator, you might have to type in 31 and then hit the tangent button, but you should get 0.60086 and so on. Okay, so on the left side of my equation I have 0.60086. Now what I can do is I can write this as a fraction as long as I put a 1 underneath it. You can write any number as a fraction to put when you put a 1 underneath it. Then I'm going to cross multiply. This is a technique that helps us solve proportions. So cross multiplying this way would give me 0.60086 times x. And on this side I have 1 times 17, which is 17. Then we're going to do what we always do. We're going to divide by the number in front of the x, right? So 0.60086x divided by 0.60086. On the other side, we're going to take 17 and divide by that value. And so finally, x is approximately 17 divided by that. So we get 28.2927. Now they didn't tell me how to round this off, so I'm going to say 28.3 is my answer. Okay, so we can use that same basic technique to find some other answers. We can use tangent, set it up as an equation, and then solve the equation. I'm going to skip number 8, mainly because I don't have a lot of space here to work with. So, number 7 has an angle down here. I'll use that as my reference angle. Opposite from that is this length. This is my hypotenuse, and that must mean down here is my adjacent. So if I'm using tangent, the tangent of some angle equals the opposite side over the adjacent side. That will work with this triangle. I can find x having been given 15. So my equation is the tangent of my angle, which is 60 degrees, equals the opposite side, which is 15, divided by the adjacent side, which is my unknown. Okay, then I go to my calculator, making sure that it's in degree mode, and I find the tangent of 60 degrees. So tangent of 60 degrees equals, I get 1.732 approximately. And so I'll write that as a fraction by putting a 1 underneath, and that allows me to do some cross multiplying. So 1.732x, and 15 times 1 is 15, and then I will solve for x by dividing both sides by 1.732. So I get x to be approximately 8.66. Now here they want me to round to the nearest tenth, so that would be 8.7. Number 9. We have a reference angle we can use here in the corner, that's 40 degrees. Then the side farthest away from that would be the opposite side. This side down here is the hypotenuse, because it's across from the 90-degree angle and it's the longest side. That's the characteristics of the hypotenuse. And then finally, whatever side is left over, that would have to be your adjacent. So if I use the tangent formula, tangent equation, the tangent of an angle equals the opposite side over the adjacent side, we would say that the tangent of 40 degrees equals the opposite side, which is x, divided by the adjacent side length, which is 20. Now remember, this right here you can find on your calculator. So you'll punch in the tangent of 40 degrees Again, some of you may be typing in the 40 and then the tangent. Just as long as your calculator is in degree mode, you should get 0.839096. I'm just going to use the first three, 0.839. And so if I write that as a fraction, I can do that by writing it over 1. And then this answer comes up pretty quickly compared to the first two examples on this page, because if I multiply 1 times x, I get x. And then if I multiply this times 20, I get 16.78. So x turns out to be approximately, rounding to the nearest tenth, 16.8. So we use trigonometry to find things that are hard to measure many times, where we're measuring across a distance of water, like oceans or lakes, or just things where it would be hard to put a tape measure on. So this example at the bottom of the page has to do with measuring the height of a lighthouse. You can see that's our unknown right there, h. And so we can easily measure across the ground from the center of the lighthouse over to the edge. And then we have these ways of measuring angles, where we know what horizontal is, and we can measure that up to where we're looking at the top, and we can take that amount of degree difference there. So using the things that are easy to measure, we can use trigonometry, specifically the tangent ratio relationship, to find this height that would be harder to measure. It's called working smarter, not harder. So using 62-degree corner as our reference angle, then this side here would be our opposite side. The length from the top of the lighthouse down to the point where you measure the angle is our hypotenuse, which means that this side over here, the remaining side, is our adjacent. So using the tangent equation, the tangent of our angle is 62 degrees, equals the opposite length, which is h, that's our height we're trying to find, over the adjacent length, which is 100 feet. We'll do what we've been doing on this page to solve. We will use our calculator to find this as a value. So I'll say the tangent of 62 degrees is 1.8807, let's call it that, approximately. And if I take my 1.8807 and write it as a fraction, I can do that as long as I put a 1 underneath it. It is the same number. And then I just cross multiply. H times 1 is h. 100 times 1.8807 is 188.07. So our height is 188.07 feet. They want us to round that off to the nearest foot. So it's approximately 188 feet tall, this lighthouse. Now the next page is just more of the same types of examples. At least it looks that way. Until, let's see, find the area of the triangle. 1 second here. Oh, has tabs. Okay. Okay. But if you read the directions carefully, this one says find the area of the triangle. Okay, so that's actually taking it a step further. The example at the top of the page is like the ones on previous pages, but once we get to 19 and 20, it's a little different. The question has changed. They don't just want you to find the unknown, they want you to find the area of the triangle. So I'm going to use this space up here. I'll show you the answer to this one, but again, it's pretty much the same as what we've been doing on previous pages. It's identifying the reference angle, the opposite side from there, hypotenuse and adjacent, setting it up, tangent of the angle equals opposite over adjacent, finding the value here in your calculator, cross multiplying and getting your answer. So we've done many of those examples already. I didn't feel like we needed to do yet another one, but in case you really wanted to do it on your own, there is the answer. Running off to the nearest foot. Okay. All right. So how do we find the area of a triangle? Well, I'm going to use this space up here on this page. The area of a triangle is 1/2 times the base of the triangle times the height of the triangle, right? Well, base and height are kind of relative. Sometimes when you're looking at a triangle like this, then this would be the base. And if you're looking at the triangle like that, then this would be the base. It all depends on how you're looking at it. It's called the orientation. So, well, if this is the way we're looking at it, that's the base. And then this would be the height. The height is, assuming the base is the bottom, the distance from the highest point straight down to the bottom. So if we want to find the area of this triangle, we're going to need to find the height first. And so what we can do is we can use our tangent relationship in order to find that height. Then we'd have both the height and the base in order to use, have all our values in our area formula. So it's kind of a two-step process. All right, so first I'm going to use my tangent. Tangent of an angle is the opposite side over the adjacent side. So if this is my reference angle, the side farthest away is my opposite. The longest side, also the side across from a 90-degree angle, is the hypotenuse. And then whatever side is left over is my adjacent. So I have the tangent of 35 degrees equals x over 14. This we find on our calculator. So I would type in the tangent of 35 degrees, and I would get 0.7002 as an approximated value. And then I would write that as a fraction by writing it over 1, and then I would cross multiply. 1 times x is x. This value times 14 is approximately 9.8. Now, how do we find the area of this triangle? Well, the area of a triangle is 1/2 times the base. This triangle is sitting on the bottom here, which is 14, that side length, times the height, which we just calculated to be about 9.8. So our area is approximately 1/2 times 14 times 9.8. So 0.5 you can use in your calculator instead of 1/2 times 14 times 9.8. So you get an approximated area of 68.6, rounding to the nearest tenth, square feet. Don't forget to put the square on the feet, not on the number. Alright, we can do one more like that, number 19. If 30 degrees is our reference angle, then the side farthest away is my opposite, so that would be this one up here. This is my hypotenuse, it's my longest side, also across from the 90-degree angle, that's our hypotenuse. And then whatever side left over would have to be the adjacent, so that means that's the one. So the tangent of any angle equals the opposite side over the adjacent side. So the tangent of our angle, which is 30 degrees, equals the opposite side, which is 10, over the adjacent, which is our unknown. Oops, not on the screen. Sorry about that. So the tangent of 30 degrees, I can plunk that into my calculator, and I get 0.57735. If I put this over 1, that allows me to write it as a fraction, which then allows me to solve this as a proportion. So if I cross multiply both ways, this decimal times x is 0.57735x. And then multiply that way, 1 times 10 is 10. So I'm going to go ahead and divide both sides by the decimal in front of the x. And I get an x value of approximately 17.32. So, does that help me find the area? That's the question. Well, if I take this triangle and I turn it sideways, like that, do you see how that side we just found, the 17.32, would be the base, and then this would be the height, the 10? Yeah, base, and height is from the highest point above that straight down to the base. Yes, this is straight down because it's a right angle. So I'm going to identify my base as 17.32 in length and my height as 10 in length. But it took a little change in perspective to do that. So the area of this triangle is about 1/2 times base, which is 17.32, times height, which is 10. Now the weird thing is, if you turn the triangle completely upside down, then the base becomes 10 and the height becomes 17.32. You'll find that either way, you'll get the right answer. So 0.5, which is the decimal approximation of 1/2, times 17.32 times 10 gives you an area of this triangle of approximately 86.6 square centimeters. Remember to put the square in the centimeters, not the number. Okay, and then the last example, I'm just going to show it to you. This would be more of an A-level type problem. Here is my solution for the skyscraper problem, and my final answer is here.